Hi, my name is Ren, and for my data analysis report, I decided to compare the volatile organic compound or VOC profiles of three different plant species, the Festuca rubra, Ficus microdetia, and Arabis alpina. These are grass species, fig plants, and alpine flowers, respectively, and I hypothesized that they would have very different VOC profiles because of their different geographies, different climates, and different multi-trophic interactions that they engage in, different pollinators and different predators in each ecosystem. And this hypothesis was mostly supported. I found that the Festuca rubra had a significantly different VOC profile than the other two species, but there was some overlap between Ficus microdetia and Arabis alpina. I decided to run a principal component analysis, or PCA, because this is a multivariate type analysis in which we are trying to make conclusions about an entire VOC profile rather than just comparing a few different emission rates between different compounds. And the ggplot here shows a simple cluster analysis here in which we are basically differentiating the different profiles from one another. And they're color-coded here, showing that the Festuca rubra had the most significant differentiation in VOC profile, as it's all concentrated on the horizontal axis. And the other two species, Arabis alpina and Ficus microdetia, are overlapping to some extent, meaning that their VOC profiles, in terms of compound classes, do have some overlap there. The reason it's important to study VOC profiles comparing them between plants is because VOCs dictate the multi-trophic interactions that plants engage in. This includes plant-pollinator interactions, plant defense, plant-to-plant communication, and VOCs are also a strong predictor of plant stress. So it's widely important to study these interactions because VOCs tell us a lot about what stresses a plant are experiencing. This could be in terms of climate, this could be in terms of population dynamics of insects, herbivores, or other plants around them. So VOC profiles tell us a lot about what a plant is experiencing and reproduction, plant defense, and things like that. I collected VOC emission data from three different papers for this meta-analysis. Each three of these papers had the different plant species, and it was all raw emission data. Emissions for each of these different types of compounds. For example, phenylacetaldehyde, acetophenone, ethylbenzoate were examples. And all of the units for emissions were already equal between all of them. It was in nanograms per hour for each flower of the plant, so I didn't have to do any conversions. And I just combined the data sets into one and classified all of the compounds into several different types. We have different types of terpenoids like monoterpenes and sesquiterpenes. We have alcohols, ketones, esters, and I combined it into one data table, which was 10 by 161. So there were a lot of different dimensions. And this is how I created PCA. I conducted this PCA in RStudio after uploading the dataset I had created in Excel. When I uploaded this dataset into R, I found that there were 9 principal components that explained the variation of this dataset. The first 2 principal components explained over half of this variation, which is basically the spread and distribution of the dataset. The first 2 PCs are plotted here on the right with this ggplot. I thought the ggplot was the most effective way to plot the difference in VOC profiles among the 3 species because it used cluster annotation. The clusters are a really visually appealing way to show the difference, as we can see the different concentrations and the different sizes of the clusters that really show the spread, the distribution, and how different these profiles are. And thank you for listening for my presentation.